Welcome to the Math 1 lesson summary video for the task, the water park. This is a solidify understanding task, and as you can see, the purpose is to interpret features of functions in context. So Allie and Dane work together at a water park, and they have to drain water at the end of each month for the ride they supervise. Each uses a pump to remove the water from the small pool at the bottom of their ride. The graph below represents the amount of water in Allie's pool and the amount of water in Dane's pool over time. So we have Allie is A of x and Dane is D of x. So question 1 asks us to make as many observations as we can. And there's tons that you could make. Some of the most important ones you might want to notice is that Allie's pool drains faster, and similarly Allie's pool is more full or starts more full. And since Allie's pool drains fastest, Dane's pool will take the longest to drain. You can make tons of other observations based off just what's given here. And notice that we're comparing time on the x-axis with amount of water in gallons on the y-axis. So that's important to keep in mind. So we go on to part 2. And it says Dane figured out that the pump he uses drains water at a rate of 1,000 gallons per minute and takes 24 minutes to drain. So that's key information we can write up here. So Dane's pool drains at 1,000 gallons per minute and it takes 24 minutes to drain. So now we have some measurements to add context to this graph. So we can go ahead and label this as 24. And so if we check the scale, we now know that the scale is going by ones in terms of minutes. And so that means that Allie's pool takes 20 minutes to drain. So if Dane's pool takes 24 minutes to drain and it's doing 1,000 gallons per minute, we can use some critical thinking to discover that it's going to be 24,000 gallons of water that he started with in his pool. And so based on that, the scale must be by 4,000. So we have 4,000, 8,000, 12,000, 16,000, 20,000, and that means that Allie's pool started off with 28,000 gallons. So if we had 28,000 gallons in Allie's pool and it took 20 minutes to drain, if we simplify that, and that tells us that her pool is draining at 1,400 gallons a minute. So now we've labeled the graph based on all the information we've been given. And now we can write equations for each of the pools and their draining. So Dane's equation, this is a linear function. So it started at 24,000 and it's draining at 1,000 gallons per minute. So y equals 24,000 minus 1,000x. And Allie, that's going to be y equals 28,000 minus 1,400x. So those are our equations for both of the scenarios, for both people. So from the information we now have on the graph, you'll be able to answer the other questions in part 2 where it's asking you to state the domain and range for each person. Since we're talking about time and gallons, they are going to be continuous intervals, so just keep that in mind to help you. So let's go to part 3. We want to answer some of these questions, which are helping us to interpret these functions in context. So it says, when a of x equals d of x, what does this mean? So first of all, let's look at the graph and see when does a of x equal d of x. So that's right there where the two functions intersect. A of x equals d of x. So what does that mean in context? That means that tells us where the time at which the pools will have the same amount of gallons in them. And so let's find out specifically what time that's going to be. And I can see visually, it looks like that point is going to be 10, 14,000. But let's just verify that. So we're really talking about solving the equation 28,000 minus 1,400x equals 24,000 minus 1,000x. So we could add 1400x on both sides, and at the same time subtract 24,000 on both sides of the equation. And so those will cancel out, and I will get 400x equals 4,000. And I can divide both sides by 400 to get that x equals 10. And so if we substitute x equals 10 into Dane's equation, we'll get that y equals 24,000 minus 1,000 times 10, and that turns out to be 14,000. So this point here is correct. So at 10 minutes, both pools will have 14,000 gallons of water. To find A of 5, we need to use Allie's equation. So y equals 28,000 minus 1400x, but I'm replacing x with 5. And so that's going to be 28,000 minus 7,000, because 1400 times 5 is 7,000. So that's 21,000. And that means at 5 minutes, there are 21,000 gallons of water. And that is in Allie's pool. Similarly, we could answer a question like number 9. So the equation for d of x for Dane's pool was 24,000 minus 1,000x. And we want to know when that's going to equal 2,000. So we can now solve this equation, which I'm going to do down here. So we could subtract 24,000 on both sides of the equation, and we get negative 1,000x equals negative 22,000. And then divide both sides by negative 1,000, and we would get the x equals 22. So that's telling us for number 9 that at 22 minutes, Dane's pool had 2,000 gallons. And you probably could have figured that out just by thinking through it logically without solving an equation, but I just wanted to show you that connection. And we can see that on the graph at 22 minutes, right here. That makes sense, that point to be 2,000 gallons. Thanks for watching. If you need help with the Ready, Set, Go videos for this task, then check out the student support site in Canvas.